Okay, so let's get started. We're going to be taking a look at how to work with our trigger scope function found within our PCLink software. Now, our trigger scope is going to allow us to evaluate our cam and crank inputs from our engine that we have wired into our link. We want to make sure that we're counting the correct number of teeth so we can program the correct pattern type within the link so it knows how to detect the pulses coming from our cam and crank sensors. We also want to make sure if we have the reluctor VR magnetic style sensor type for either our trigger 1 or trigger 2, which is our cam and crank, that we are defining the correct arming voltages. Now, I'm probably talking about some things at this point that you're not familiar with, this terminology. We'll actually be taking a look in the next 2 training modules after this at Hall effect trigger setup and VR reluctor style setup. I'm going to have 2 different videos for that, discussing the specific details so we can get into this a little bit more in depth. But what we first need to know how to work with is our trigger scope. This allows us to measure the raw waveform coming out of our triggers, cam and crank trigger, and it allows us to then program things properly within our link software. How do we work with this? What does this all represent here? All right, let's jump in and take a look. I'm in the fuel page right now in the course layout. I'm going to move over here into the page labeled cam crank. Now in here, we're going to define the actual pattern that we're dealing with. We can see that trigger mode. We have an option here. We can go down and select a lot of different trigger patterns depending on which specific engine we're working with. In my case, I have a generic universal type of pattern. I have a 12 missing 1 on my crank. So it's going to be my how many pulses that we should see within an engine cycle. So we'll have 12 pulses, but I am missing a tooth, which is common. And then I have 1 pulse on my cam input, which is also very common. So in this case, I'm selecting multi-tooth missing option here, click OK. Now, if you didn't know what specific pattern your engine was fitted with, you could go in and automatically go into the trigger scope and start trying to work with it to actually see that information. I do know some of this information, that's why I can just populate it now. It's always best if you have an idea of what you're working with to go in here and start to fill out some of your details. So there's trigger 1, which is our crank input, trigger 2, which is our cam input. Now, the trigger type, it's either going to be a reluctor, which is a magnetic style sensor, or optical Hall, which is going to be a powered style sensor, and that produces a square wave output. The difference between the reluctor that generates its own magnetic voltage field based on the sensor and the tooth passing over it, and then the optical Hall generates a 0 to 5 volt pulse. We'll get into more specifics with this, but I have an optical Hall. You can tell if you have a reluctor style sensor or an optical Hall style sensor if you're trying to figure out what kind of sensors you're working with if you don't know. Generally speaking, a reluctor will have 2 wires. A optical Hall can have 3 wires. So that's usually the easiest way to know what you're working with for either your trigger 1, which is your crank input, and trigger 2, which is your cam. Now there are a couple more details here associated to the setup. There's a trigger pull-up, trigger edge, and multi-tooth position. Well, the multi-tooth position in my case, I have the actual trigger wheel fitted to the crankshaft. If it was on the camshaft, cam driven, you would select cam. The pull-up and the trigger edge are specific to the sensor type we're working with. Generally, with an optical Hall, we'll have the pull-up on and we'll have the edge set to falling. We'll get into more of these details and what they actually represent again in our Hall effect specific tutorial. Now the tooth count, I know in this case that I have 12 total teeth on my trigger wheel. Now technically it's a 12 missing 1. So we always say in this particular parameter here, the tooth count, we count the total teeth even if it's missing 1. So if you had a 36 missing 2 trigger wheel, which is another common pattern, you'd list this as 36, not 34. The missing teeth in my case is 1, so we specified here, and the number of gaps would be 1. So we need to go in and figure out, just fill out the basic information. And again, if we don't know this information, you could use the trigger scope to actually capture it and take a look at it. The trigger 2, we have some of the similar information. I have 1 pulse in the cam. That's an optical Hall, 3-wire sensor. Pull-up is on, edge is falling. So these details should be filled out if at all possible before you start. If you don't know your actual sync mode, how many pulses will come in here in your options, we have a couple different options here. If you don't know which actual mode applies to your engine, you'll have to use the trigger scope to find that information out. But I filled out the basic details here. And now we can jump in When we go to ECU controls, in our drop down all the way at the bottom here, we have this window called Trigger Scope. What this is going to do is allow me to, typically if we're trying to figure out some of the details for this information in here, we're going to go ahead and crank over the engine and click capture. When we do this, it's going to generate whatever the signals are coming out of our trigger 1 and trigger 2, so the crank and cam. It'll generate that on screen here. We can actually evaluate the real pattern with our engine. Let me go ahead and do this right now. We can see the engine speed is currently reading 0. So if I go up here and I start to crank over my engine, we can see my engine's cranking right now at about 117 RPM. If I go ahead and click capture, give that a second, we should find here that it does capture a new waveform. Let me go ahead and stop cranking. So looking at this, what we're finding is that in this window, if we go to our triggers window, there's a couple different windows to take a look at. This is going to show us the actual pattern we're working with. So each pulse that we find right here is going to be associated to each tooth count. We can actually go in here and click, and we can use the up arrow or the up arrow here on the keypad to be able to go in and zoom in or zoom out. So the down would allow us to zoom out, up would allow us to zoom in. So we can count this a little bit easier. What we're looking for here is to get confirmation that I do in fact have a 12 missing 1 crank trigger wheel. We can go in here and count these individual pulses. We do notice that
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.